Welcome. Today's objectives are, after watching the next 3 videos, you will be able to draw orbital notations of the elements, write electron configuration and noble gas configurations, and predict the electron configuration based on location on the periodic table. In order to do this, there are 3 rules that we must follow. So if you'll find this foldable, and once you have found the foldable, which you cut out right before we left for fall break, and find the sheet, fold it hamburger style so the title is more visible. So right here is that fold line. So you'll fold that in half, hamburger style. And then you're going to glue it in your ISN after the notes we put in from fall break. Before fall break, actually. If you need to go to a new page, do so. Once you have this glued in, you will cut this sheet right there in those 2 spots so that you make this a 3-tab foldable. Alright, now once that's in, there are 3 rules that we must follow with quantum mechanics. The first one's called Aufbau's principle, and that states that electrons fill in the orbitals with the least amount of energy first. This is a low energy state of electrons and is referred to as the ground state. So that is this rule right here. On the outside of that, you're going to write Aufbau principle down. Go ahead and get these titles in. Aufbau principle, Pauli's exclusion principle goes in the middle, and then Hund's rule. So your 3 rule names on the outside of this foldable: Aufbau principle, Pauli's exclusion principle, and Hund's rule. Oops, wrong slide. Alright, so with Aufbau's principle, we're going to use this chart that tells us that electrons fill the lowest energy orbitals available, and the orbitals are going to be represented with lines when we draw these orbital notations. The chart you have, you glued it in on an index card. Please do not glue that into your ISN because you'll be constantly flipping back to that page. So don't glue in the chart that you have that's on an index card. It looks very similar to this. Highlight the little lines on there, yellow. We'll use this chart because it tells us the order the electrons fill in, keeping them going into their lowest energy orbital that's available first. Alright, the second rule again is the one in the middle, and that was Pauli's exclusion principle. And this is where 2 electrons can fill a single orbital, but only if the electrons have a different spin. So again, the orbitals are going to be represented with these lines. Those are the circle, dumbbell shapes, and then the clover leaf patterns in S, P, and D. So we're just going to we're representing those orbitals with straight lines. And a positive spinning arrow for our textbook is shown as an up arrow, and a negative spinning electron is a down arrow. So anytime you're drawing electrons on the line, first there's only 2 electrons, and second you always want a positive spinning electron first and then your down arrow. The 2 wrong ways of doing this would be this, where you put 2 positive spinning electrons up on the line together, or 2 down. Another way this could be wrong is if you put the negative spinning electron down first and then the up arrow second. So that's another one that you need to add. So add the arrows to your foldable. Alright, the third rule is the third and last rule here that we're following is Hund's rule, which states that electrons fill each orbital with a positive spinning electron first before electrons pair with negative spinning electrons. So if you have more than one orbital, which will occur in p, d, and f orbitals, you will need to put a positive spinning electron on those lines up first. If you need all these three, you put them in up first before you start pairing down. So don't do this. You have 3 lines. Don't put those 3 like that, because that would be wrong. Okay, so you're always, if you need 3 electrons in your P, you're going to have 3 arrows pointing up first. All right, so the pattern here is that we're going to go, and down here at the bottom of the tab, we're going to put an arrow up on the first line. If you need 2 electrons, then you would have 2. If you have 3 electrons that are needed in this p orbital, it'll look like that. If you need 4, that's when you can start pairing down. Now that should sound kind of, let me erase that one because that's not the right way. Should be familiar to you, because when we're doing Lewis dot structures, let's say for carbon, you put a dot on each side instead of pairing those up. If we were doing oxygen with 6 valence electrons, you put 1 on each side, then you started pairing up those electrons. There's an electron right there too. Okay? So draw in all the electrons, and again, you go up first if you need all of those. If you need 4 electrons, that's the way the 4th one goes in. If you need 5, the 5th one goes in next. If you need 6, then it's down. So fill in these electrons there. All right, so on your next test, you will need to know the Aufbau principle, Pauli's exclusion principle, and also Hund's rule. So get those rules memorized, and we will use those in the next video.